Jeff Mucklin here with the Nurture Nature Center, and this is Science at Home. I was just enjoying watching the snow come down right now. Snow and ice can mean different things to different people. For some, perhaps the younger people in the audience, it means sledding and snowball fights and maybe a day off from school. For others, it means shoveling and navigating difficult driving conditions. Now, I do not like shoveling any more than the rest of you, but I don't have anywhere I have to go right now, so let it snow, let it snow, let it snow. Let's go outside and get a better look at it. I love the way the city looks under a blanket of fresh fallen snow. And individual snowflakes are really quite beautiful as well. Snowflakes start out as water droplets that condense onto particles in the atmosphere. If it's cold enough, those water droplets will freeze into crystals of ice. And each of these crystals is unique. But there are actually just 4 different major categories that most snowflakes fall into. And these are needles, columns, plate, and rime. But there are many more subcategories. There's a website called snowcrystals.com that has a convenient chart that lists 35 of these subcategories of snow crystals. Snow can fall as individual snowflakes like it is right now, or it can form larger clumps like it was earlier that you might have seen out the window. And that typically happens when the air temperature is close to the freezing point, close to 32 degrees. And it happens because as the individual snow crystals are falling through the atmosphere and they encounter a warmer layer of air, the surface of the crystals melts slightly. And now these wetted crystals can stick together and form those larger flakes. So if you see large flakes of snow, it means that the air temperature is close to the freezing point. Well, it snowed all night and it's still snowing and it's expected to continue to snow for the rest of the day. But I'd like to see how much snow has accumulated so far. But I have a bit of a problem. How do I do that? I have a meter stick here, but where do I actually measure? If I place it here, I only see 5 inches of snow. If I place it here, I see 13 inches of snow. The wind has been blowing very hard today. There's been wind gusts of up to 25 miles per hour. So there's drifting snowbanks forming. And I can't get an accurate measurement of the snow total. The answer is to measure the snow depth in an open field where there is no drifting occurring. So this is a pretty large open space. There isn't any drifting snowbanks forming here. It's a good place to get an accurate measurement. So let's place our meter stick in the ground. I'm seeing 11 inches, so just under a foot of snow has already accumulated. And the forecast says that we're supposed to see anywhere between 15 to 20 inches of snow accumulation with this storm. Well, it's 2 days after the big snowstorm. It ended up being a lot more than predicted. It was actually over 2 feet of snowfall. But it's starting to melt today. And as I look around, I notice all of this white, which is a little bit strange because individual snowflakes are clear. They're clear crystals of ice. So why does snow appear to be white? Well, it's because a small amount of light reflects off of the surface of each crystal. And if you get even a relatively thin layer of these crystals piled up on top of each other, collectively they reflect enough light back to appear white, but they are not actually white. By analogy, I have here a piece of bubble wrap, and you'll see that the bubble wrap is clear. You can see me through it. But if I just fold it up a few times, it appears to be white. But that's because a small amount of light is being reflected off of each layer of the bubble wrap, and together they reflect back almost all the light that hits them, making them look white. You may have seen pictures of blue banks of snow or blue glacial ice. Ice is not blue either. But if you have a thick column of relatively clear ice, blue light ends up being scattered more than other colors, and so that makes the snow look blue, or the ice look blue. Another interesting fact about snow and ice is that they're both really good insulators. And this is why, Inuit people living in the far north have been building igloos for millennia to survive in the brutally cold conditions that exist north of the Arctic Circle. But inside this snow bank, it is 30 degrees. But outside of my igloo, it's 22 degrees. It's a lot colder just outside here. Another interesting property of snow and ice for the Earth at large is the fact that it appears to be white. In this image of the Earth, you can see the North Pole as this very bright white region. And if we rotate towards the South Pole, we can see another very bright white region. That's the Antarctic. Light surfaces reflect energy away from them. They do not absorb it, whereas dark surfaces absorb energy, and that makes them hotter. So the fact that the North and South Pole are already quite cold places allows them to accumulate snow and ice, which reflects energy from the sun away back into space, which makes these areas even colder. We call this a positive feedback. So despite appearances, snow is just tiny particles of clear ice. And ice is just the solid phase of water, which is a liquid above 32 degrees Fahrenheit at standard atmospheric pressure. But below 32 degrees Fahrenheit, water becomes a solid. Ice crystals expand and they become less dense than liquid water. This is really strange, stranger than you might think. For just about any other substance you can think of, the solid form of it is denser and will sink in the liquid form of that same material. So for example, a solid block of wax, if placed into a pool of liquid wax, is denser and will sink into that liquid pool of wax. And that's true for different metals. Solid iron will sink in a pool of liquid iron, and so on. Pipes can burst on really cold conditions because the water in your pipes will expand, and it will expand with enough pressure to burst through even a very strong metal container, so your pipes really don't stand any chance at all. So the fact that water expands as it becomes ice is bad for your piping, but what does this mean for the Earth? Well, I'm going to show you. I have here two glasses that I have filled with water, and we're going to add some ice to this glass, and we're going to mark what the water level is after we've added the ice. And to this cup, I'm not going to add any ice to the water itself, but I will put some cubes of ice in this cup, which is above the cup of water, and it has a hole in it, so as the ice melts from this upper cup, it can drip into this cup down here. And we'll mark the water level in this one as well. So I've placed a piece of black tape on both glasses to mark the water level. This is the glass that doesn't have any ice cubes floating in it, but has some ice cubes above the glass. And this is the cup that has the ice cubes floating in the water. There's the same number of ice cubes being used for both cups. As they melt, you might wonder what's going to happen to the water level in this cup. Will the water level change? Will it rise? Will it go down? Or will it stay the same? So after about a half an hour has passed, the water level in the cup with the ice cubes floating in it has not changed, and the ice cubes have mostly melted. But as they melted, they went from being a less dense ice crystal to a more dense liquid. So they didn't change the water level at all. But if we look at the glass over here, where the ice cubes were above the glass and dripping and falling in, the water level there has changed. If you enjoy the intricate beauty of a snowflake, then you're really going to enjoy this week's at-home activity, because I'm going to show you a way that you can actually preserve your own snowflakes indefinitely. To do this activity, you're going to need some fresh fallen snowflakes, and you're going to need some super glue and some microscope slides and cover slips. And you're also going to need potentially some mittens so you can avoid melting your snowflake. But if you put the snowflakes on a chilled microscope slide and then put a dab of chilled super glue on them and apply your cover slip and then leave that in your freezer in your home for about 2 weeks, the super glue will eventually harden around the snowflake. And then you can take the microscope slide out of the freezer and the snowflake will melt, but its shape will be preserved in the hardened super glue around it. We'll be sharing a link with detailed instructions of how to do this at-home activity. Thanks for joining me in this week's Science at Home video. I hope you get out and enjoy the snow, and I hope to see you next time. See you later.